So, in this subtopic, there are several formula that you must memorize to answer the problem solving question. Okay, the question that involve calculation. Okay, so I'll just go through one by one. Okay, for the first one, okay, if you look at the question asks you to calculate the energy of an electron at energy level 3. If you look at this question, there is no electron transition. The question just asks you to calculate the energy of the electron when the electron is at level 3. So actually this question involves the energy of the electron at stationary state. It means that the electron does not make any transition. It's just stay at that level. So the formula that you are going to use is En is equals to negative RH times 1 over n squared. Okay, so the RH value here, this one is the Rydberg constant. The value here, since this is the energy, the value of this RH is 2.18 times 10 to the power of minus 18 joules. Okay, so kenapa saya mention this value? Because you are going to see two different values for Rydberg constant. So if you want to find the energy, the value of RH must be in joules. So since the question asks you to find the energy of the electron at level 3, so N is equals to 3, substitute it into this formula, substitute everything into this formula, and then press your calculator, you will get negative 2.42 times 10 to the power of minus 19 joules. Okay, so this value is fixed. Okay, if the electrons are at the energy level 3, it will have this energy. Okay, it does not change. It cannot be in between. Okay, dia mesti this value. That's why, okay, kita kata energy is quantized. So, kalau perasan, the energy of the electrons at each level comes with the negative sign. So, kenapa agaknya the negative sign? Kenapa bukan positive sign? So, actually, okay, when the electrons are far away from the nucleus, so let's say dia duduk jauh sangat sampai n is equals to infinity, we said that the electron is free from the attraction from the nucleus. So, the energy at infinity is 0. Okay, tetapi okay, semakin dia dekat dengan nukleus, okay, kalau dia makin dekat dengan nukleus, okay, there is an attraction between the nucleus and the negative charge of the electron sebab dekat nukleus ni sebenarnya ada juga proton. Okay, so proton ni charge dia adalah positif. So the electron charge dia negative. So there is an electrostatic attraction between the nucleus and also the electron that makes the energy of the electron at each levels negative. For the second example, okay, saya akan tunjukkan how to use the second formula. Okay, so for example here, determine the frequencies of light for the 410.0 nanometer. So dekat sini, okay, from this question kita dah ada frequency of the light which dia minta frequency of the light which is nu. Okay, frequency of the light berapa and then diberi lambda. Okay, so kalau ada dua benda ni, okay, kalau ada frequency and juga lambda, perkaitan antara frequency dan juga lambda adalah, okay, perkaitan dia adalah nu is equals to C over lambda. Okay, so dalam formula ni dia ada perkaitan antara frekuensi dan juga lambda. Okay, di mana C is speed of light. Okay, dia adalah constant which is 3.0 times 10 to the power of 8. meter per second. Okay, so kita dah ada lambda, kita dah ada C, kita boleh cari frekuensi. But the problem here, the units given for the lambda here, the wavelength here is nanometer. Okay, tapi dalam speed of light, okay, unit dia adalah meter. So you have to use a conversion factor to convert from nanometer to meter. So how to do this? Okay, so 1 nanometer, okay, is equals to 10 to the power of minus 9 meter. Okay, sebelum ni saya dah ajar banyak kali fasa conversion factor, so sepatutnya awak tak ada masalah lah. Okay, so the given unit here is 410.0 nanometer. Okay, kita darabkan dengan, okay, so nanometer kita kena cancel outkan dia. So 1 nanometer akan duduk dekat bawah. So 10 to the power of minus 9 meter akan duduk dekat atas. So you akan dapat the wavelength in meter. Okay, bila you cancelkan nanometer dengan nanometer, dapat meter, which is 4.1 times 10 to the power of minus 7 meter. So dah dapat yang unit meter, baru boleh guna this formula to find the frequency. Okay, so substitute the value. Okay, so dekat sini kita boleh cancel out the meter. Okay, and then your final unit should be in per second. Okay, so the unit for frequency is per second, ataupun you boleh tuliskan dia sebagai 7.32 times 10 to the power of 14 Hertz. Okay, per second pun boleh, Hertz pun boleh. Hertz adalah 1 Hertz sama dengan 1 per second. So dapatlah dia punya final answer. Okay, so ingat kalau diberi wavelength dalam bentuk nanometer, you have to convert it into meter first, baru boleh guna dalam formula sebab speed of light dalam unit meter. So sama juga you boleh apply kalau dia bagi frekuensi, dia minta lambda. So boleh juga pakai this equation. Okay, so this equation menghubung kait antara frekuensi lambda, which is the wavelength, and also the speed of light. For the next example, okay, saya akan tunjukkan macam mana nak gunakan formula yang ketiga pula. Okay, so let's say the question asks you to calculate the energy of the photon of a radiation with a frequency of 8.5 times 10 to the power of 14 Hertz. So here, okay, the question asks the energy of the photon. Okay, energy of the photon, and then given the frequency, which is nu. Okay, so sekarang ni perkaitan antara energy dengan frekuensi pula. Tadi perkaitan antara frekuensi dengan wavelength. Okay, so for this type of question, okay, perkaitan antara energy and frequency, you can use this formula. Energy of the photon is equals to h nu, where h is the Planck constant, which is 6.6256 times 10 to the power of minus 34 joules seconds. Okay, so tak payah risau. Okay, dia punya constant value ni akan diberi dalam soalan. Okay, so since kita nak cari energy, kita dah ada frequency, kita dah ada h. Okay, just substitute the value into the formula. Okay, so ingat balik, Hertz ni 1 Hertz adalah 1 per second. So tukar dia kepada per second. Okay, so kita boleh cancelkan the second. You will get the energy in joules. Okay, so energy ni mesti dalam unit joules. If you press your calculator, you will get your answer 5.63 times 10 to the power of minus 19 joules. So katakanlah soalan minta energy of the photon berapa. Okay, dia minta energy of the photon berapa, tapi instead of dia bagi frekuensi, okay, dia bagi wavelength. Wavelength dia bagi. Okay, wavelength dia bagi. Alright, so macam mana nak selesaikan this question? Okay, sebenarnya kita akan pakai this formula as well. But we are going to substitute nu is equals to C over lambda. Okay, so kita akan pakai energy of the photon, okay, is equals to Hc over lambda. Okay, pun kita boleh gunakan. So that's it for the first part of the calculation. See you in part